Good afternoon, everybody. Welcome along to Next Generation Audio Summit 2020. My name is Will Strauss. I'm one of the editors here at SVG Europe. Thank you for joining us today. This is the first of 3 sessions this week. This one's called Get It in the Mixer, How to Achieve Better Audio Immersivity Through Object Manipulation. Before I introduce you to our host for the day, a bit of housekeeping. If you're not already wearing headphones, can I recommend you put on a pair of cans or pop in some buds right now, because that will give you the full experience of the clips and segments we're going to play for you over the next hour or so. As far as Zoom is concerned, if you've got settings controls there, please choose Speaker View, again for the best experience. If you have questions for any of our contributors today, please use the Q&A tool, which if you're on a PC or Mac, you'll find at the bottom, hopefully, of your Zoom app. Before we get going, I'd like to thank, and I'm very grateful to, Dolby for their support. Without them, we couldn't do these events. This is a long-term relationship, and particularly for this event. And to that end, we're going to hear an introduction today from Andreas Ehret, who is Director of Technology at Dolby's Consumer Entertainment Group. Let's hear from Andreas now.
Hello everyone, my name is Andreas Ehret. I've been involved over the years at Dolby designing and developing technology and products based on the concept of audio objects. So I'm very happy to introduce you to this next session, where we're going to explore and dive into some sophistication and details around object-based audio production. Object audio has been introduced quite a few years back, and fast forward to today, it is meanwhile available in hundreds of millions of devices to consumers. Those devices are ranging from high-end home audio theater systems, soundbars, TVs, smart speakers, and of increasing importance is also consumption on mobile devices like smartphones and tablets, where headphone playback is dominating, obviously, which means binaural playback. And then there's also an increase in use cases. It started in the cinema for movies, later then it was adopted for TV content. It is live on air today for live sports and events. And there's also other use cases evolving, like gaming, for example, but for example also increasingly music. And future applications like for augmented reality are just around the corner as well. Now, the adoption of object-based audio has also been reflected in production guidelines. This is true both in post-production, but also for live and real-time workflows. Just to spend a word on benefits, well, we'll surely hear some more during the session, but at a high level, it surely offers more control and more precision in your production. Conceptually, you can keep closer to actually working to mix towards a space and rather having to mix for a pre-confined speaker configuration. This approach offers then also later much more flexibility and versatility in how you play out your content and also for the downstream processing. For the consumer, this translates to a higher quality, to a better experience, to an immersive experience, and also with more choices to adapt the experience to your personal playback environment. Yet we may also, we may only have actually scratched the surface. What else is possible using this approach? For example, we may be able to give the consumer more control over which playback elements can be played back or how they are played back. That ultimately enables also new forms of storytelling, presumably. What I'm specifically curious to hear from this panel and those experts in this session are, what are your learnings? What have you done over the years, and how have you maybe changed your approach to capture for your production workflows? And what does it mean going forward? How does it maybe further evolve? And what ideas are you having in mind around future possibilities? And what potential solutions can you dream of? Now, without any further ado, let's dive in and hear from the experts.
Thank you to Andreas for that introduction. Now I'd like to hand over to our host and chair for this session. We're very lucky to have Mr. Roger Charlesworth joining us all the way from across in New England today. Roger, thank you for being part of the show and for hosting for us. I'm very much looking forward to this. I'm sure you and the rest of the audience are. So, Roger, over to you.
Great. Thanks, Will. Certainly looking forward to it today. And we have a very exciting panel. Excited to be joined by Hyunkook Lee and Ben Shirley and Felix Krückels. And, this subject of manipulation of objects is really, really very interesting. And we're just beginning to explore the possibilities. And, in the last few years, we've been on this evolution where, because of virtualization in sound bars and headphones and even mobile phones and computers, that the premium entertainment experience has sort of migrated toward the home. And certainly recent events have impacted and accelerated, as other trends in our society have accelerated that trend toward the premium viewing experience, listening experience, moving from the cinema fully to the home. And immersive audio in the home a few years ago seemed very exotic and sort of far away. And now it's sort of rapidly, for premium content, is becoming the norm. And that certainly started with pre-produced content, but now we're seeing it filtering through live content. And at first that was just special events, but now I think it's becoming the norm for premium sporting content and entertainment content. So we're looking forward to sort of delving into a little bit of the science behind how we can create better immersive experiences, how we can manipulate immersive audio in live experiences, and techniques for capturing sound fields and other objects. So I guess we're going to start with Hyunkook Lee. Hyunkook is an associate professor of music technology and director of the Center for Audio and Psychoacoustics Engineering at the University of Huddersfield. He's also a sound engineer with 20 years of experience in acoustic recording and live sound. His recent research and advanced understanding about the perceptual mechanisms of vertical stereophonic localization and image spread, as well as the phantom image elevation effect. This has helped develop new 3D microphone array techniques, such as the ORTF 3D, the PCMA 3D, and the SMA 3D. Vertical mixing and upmixing techniques, and virtual 3D panning method called VHAP. His ongoing research includes 3D sound perception, capture and reproduction, and virtual acoustics for immersive extended reality applications. From 2006 to 2010, Hyunkook was a senior research engineer in audio R&D at LG Electronics in South Korea. He's a fellow of the AES and a fellow of the Higher Education Academy. Hyunkook, welcome. It's quite some speaker array you got going on back there.
Thank you very much, Roger, for introduction. So very nice to meet you all virtually, and it's my pleasure to present at this Next Generation Audio Summit 2020. Here in my talk, I'll be briefly overview some principles behind 3D audio perception, and I'll introduce some recording techniques developed based on the principles. So let's start with brief recap about how stereo and surround works. So we localize sound spatially using interaural level difference, interaural time difference, and HRTFs and all these different cues. But in stereo and surround, basically we use the fact that our ears are horizontally spaced. So any interchannel time and level differences encoded between microphone signals are eventually translated into interaural differences, interaural level and time differences, and also interaural cross correlation. It's about how similar the two ear input signals are. And depending on the correlation level, we perceive different amount of spaciousness and envelopment. So a general rule is that if your microphone spacing increases, basically we can decorrelate the sound more, and that contributes to the perception of greater amount of spaciousness and envelopment in surround reproduction. But now we add additional height speakers on top of 5.1 or 7.1. Then now, what kind of psychoacoustic mechanisms involved in our stereophonic perception, vertical stereophonic perception? And this leads to this important question of how we should capture the sound field for the height dimension. So how do we create a phantom image between the main layer and the height layer? So two underlying questions: how do we localize sound vertically, and also how do we perceive spaciousness vertically? So I'm gonna introduce some basic principles in a minute. But if you're interested in exploring different 3D microphone techniques, there is this open access database I created last year. It's called 3D Marco. It has recordings made using 8 different microphone arrays, 3D microphone arrays, as well as lots of impulse responses captured in this lovely concert hall. So please check it out. So you can already see a lot of different microphone configurations in this picture. So usually for surround sound, yeah, as I already said, the wider the microphone spacing is, the wider and more spacious the captured sound field will appear. So does the same rule apply in 3D audio? So do we need a large cube of microphone array to capture a spacious ambient sound? For example, in sport broadcasting, to capture enveloping crowd noise, do we need this kind of large microphone array? This is a microphone array called 12Q, which is widely used in music recording in a concert hall. But for outdoor live environment, it may be too large.
Hyunkook, could you please share your screen?
Oh, did I not? Oh, no. Sorry.
No problem. No problem.
Right. Okay, now can you see it?
Yes.
Yeah, sorry, I forgot to press that share button. Sorry, but anyway, the what I already told you was just an introduction, and so yeah, for outdoor live environment, do we need this kind of large microphone array? Firstly, it's not practical for live sound broadcasting use because it's too large maybe, and there are some potential issues I will be discussing later on. But then we have this convenient ambisonic microphone arrays. This kind of ambisonic microphone array is widely used these days, but is it good enough to capture enveloping ambience in 3D? It depends. For binaural production, when you are always in the virtual sweet spot, it may deliver very accurate and enveloping sound field, but it has some problems over loudspeakers, because firstly, it lacks spaciousness, and also as you move your listening position, you may hear quite unpleasant comb filter effect. That's the limitation of this kind of coincident technique. So basically, my research suggests that horizontal microphone spacing definitely matters for delivering envelopment, but not for the vertical spacing. So vertical spacing, we can reduce it to 0, like we can see here in this ORTF 3D by Scheps, which was based on my research findings. So this vertical spacing is basically 0. So we can make it vertically constant, but horizontally spaced. And this has been psychoacoustically validated through many experiments. So next, I'll be briefly talking about some psychoacoustic principles of vertical perception. basically the way we perceive localized sound vertically depends on the frequency spectrum of the ear input signal rather than interaural or interaural time or level differences. So this pitch height effect is basically the main cue for vertical localization. As you can see in these graphs, the x-axis shows the actual loudspeaker height, and the y-axis shows the perceived image height. As the frequency goes up, regardless of the actual loudspeaker height, we perceive the sound image at a higher position in space. So low frequencies will always be localized at a lower position, regardless of the speaker height. So even if you play a 100 Hz tone from your height loudspeaker, it will be localized at your ear height or below. And I've done lots of experiments on stereophonic localization and how this pitch height effect works in 3D loudspeaker playback conditions. And I found that interchannel time difference, time delay applied to the height speaker, doesn't actually give you any convincing localization cue. So for example, in this example, we have pink noise, broadband pink noise, delayed by 1 millisecond in the height channel compared with the main channel. Normally, we would expect the earlier sound will dominate the perceived sound position by the precedence effect. That's how it works horizontally. But vertically, when you apply 1 millisecond delay to the height speaker, the image actually goes up rather than going down. So this is opposite to what happens with horizontal stereo. And with 10 millisecond delay, we cannot still localize this image at the main speaker position. So time cue is an extremely unreliable cue in the vertical domain. And also we can see for individual frequency bands, lower frequency bands tend to be localized at lower positions, and higher frequencies above 4K are localized at higher positions. So the pitch height effect still works with stereophonic sound created vertically. How about amplitude panning? This is a very popular technique used everywhere. Pan pot and 3D panning is usually done using amplitude cues. But also we can see this pitch height effect oriented phenomenon here. So high pass filtered noise above 1 kHz. There is a better panning than time panning here. We can see some pattern here, although effectively there are only 3 regions. So most of the images pan to 10 degrees. Well, the target image position is 10 degrees, but the perceived image position is just about 0 to 5. And when you apply no level difference, then we have this image in the middle between the speakers. And then the image position jumps to the height speaker positions, regardless of your target image position. But still, we can have this sort of a curve pattern. But with low frequencies, the amplitude panning never works accurately. So there's no point of sending low frequency dominant sources to your height speakers. Or if you intend to pan your image accurately between vertically oriented speakers, it usually doesn't work. So in terms of microphone techniques, so how do we capture 3D sound with these principles in mind? So when we have this microphone aiming to capture ambience for the height speakers, the problem we have here is that this microphone will capture a lot of direct sound. So this main microphone is responsible for source imaging, and the upper speaker is supposed to capture more ambience. But if the direct sound is captured by the height microphone as well as the main microphone, then we have this vertical upward shifting of the phantom image. And also we have this problem of comb filter effect. So the resulting image will be seriously colored. So you can see this comb filter pattern caused by adding the height microphones in reproduction. So what do we do now? Given the time difference doesn't work, we have to use the level difference. How much level reduction do we need to apply to the height speakers to localize the source image in the main speaker position? We need at least 7 dB for spaced microphone techniques and 9.5 dB reduction for vertical coincident technique. So we can simply angle the microphone upwards slightly so that we can achieve the 7 dB reduction of the crosstalk compared to the main signal. Then we can ensure that the source image will be localized at the ear height. And we can also reduce the coloration effect as well. But then do we really need the spacing between the vertically oriented microphones? The answer is no, because from this experiment we've done in 2014, we tested various vertical microphone spacings in 3D reproduction and measured perceived differences in spatial impression as well as preference. And as you can see in this result, there was no difference between all these microphone spacings in terms of spatial impression, and the same result was obtained for preference. And depending on the sound source type, the 0 meter spacing, this vertical constant configuration was actually preferred more, or produced a slightly more spatial impression. So using that research result, we can reduce the spacing vertically, so just make it vertical constant or XY. And then now we have to ensure that the level difference should be sufficient enough. So here about 10 dB suppression of the crosstalk will ensure that your image will be stably localized and you can have more ambience in the height. So the benefit of this is you can actually raise the ambience level a little bit higher if you want to boost the vertical spatial impression. You can also control the amount of ambience in the high channel without being affected by the direct sound. So this finding has been applied to several different microphone techniques. So this is my own array called PCMA 3D. This has this vertical constant array configuration. And the benefit of this, so here, the main microphone is capturing source and the upper microphone capturing ambience. And the main benefit is when you reproduce the sound field in 3D, it gives you very natural sort of extension vertically, not exaggerating the height, but gives you very natural extension of the vertical image. And also it's very good for 2D downmix. When you just follow the 3D reproduction for 5.1, you can just simply combine these two signals without confiltering effect. Same theory has been applied to OLTF 3D and my other array called ESMA 3D, which is 50 by 50 centimeter square array. So it's all horizontally spaced, vertically constant. So now I know I have 3 minutes left, so I'll play my binaural samples that I don't have any spot recording, unfortunately, right now, but I've captured some outdoor soundscape in Manhattan, New York last year. So it's 8-channel ESMA 3D recording. So the speaker playback has been binaurally synthesized for headphone playbacks. So here we go. Hope this works. Fine.
Attention customers, for your safety and the safety of others, please do not sit on the floor or stairs in Grand Central Terminal. Thank you for your cooperation.
briefly, this gives you an idea of how the microphone array works and how it sounds. We compared this array against FOA, first order ambisonics, and it definitely gives you a lot wider listening area over loudspeakers and better spaciousness. And also compared with a larger array, it still gives you a sufficient spatial impression and natural vertical extension. I think my time's nearly up, or it already has passed. If it is. 1 second, let me.
Well, those sounded amazing. That's really.
Oh, thank you very much.
Really amazing.
Yeah, I had some more recordings to play, but I don't have enough time for that today. So, but yeah, I hope it was useful. And now maybe you have some time for questions.
Yeah, I'm curious how the spacing, the lateral spacing, affects the height channels. I mean, I think you've talked about the vertical spacing, but are there sort of trade-offs as affects the height microphones and how large the array is laterally?
Yeah, good question. So firstly, the horizontal spacing is important for spatial impression, right? But that is actually almost orthogonal here in the vertical extension, because we suppress the direct sound vertically by nearly 10 dB or more with using supercardioid microphones facing upward. So the height layer doesn't really affect the color of the overall sound. And likewise, the horizontal spaciousness doesn't compromise anything vertically. So they have quite good channel separation. And the spacing, of course, if the spacing is wider, you can have better decorrelation at low frequencies. So low frequency envelopment might increase. But for outdoor sound capture, we also have to think about practicality, and it should be easily portable. So this 50 by 50 centimeter is based on my measurement. It gives you very nice decorrelation and wide listening area, and at least down to about 300 hertz, you have very good decorrelation. Yeah. So I hope that answered the question.
Yeah.
Okay, thank you.
See if we have any questions from the audience. Nothing so far.
Then I perhaps would step in, Hyunkook.
Yeah.
When I started to mix in 3D, I set up a special configuration. I can't remember how I did this, but to measure the correlation between more or less all my channels. Of course, front, left, right, rear, left, right, front, left, rear, right. And then I set up a couple of channels, I think with AFL, and measured front, left, low, and front, left, high. And I made sure that I had good correlation. You know, we always have to make sure that the downmix works, and the height is downmixed to the 5.1, and 5.1 is downmixed to stereo, and in the end to mono. Yep. Which is a bit pain for us in broadcast, that we still have to consider broadcasts from the 50s and the 60s, however, a long time back. But this means that actually, because it's more or less completely decorrelated, your height layer and the main layer, I don't have to pay attention at all.
Exactly.
To correlation.
Yeah. So
does it also mean that because of your psychoacoustic research, I don't have to pay attention if there is some phase issues between height and main layer?
Phase issue is almost none. Of course, there is some practical limitation when you configure your microphones. The capsules are slightly spaced apart, like 1 centimeter or so, but that gives you coloration only above like 12K or 13K, which is not important. But as I showed the graphs with the spaced omni array, it gives you the coloration from like very low frequencies, and it sounds pretty much colored, especially for crowd noise and applause, that kind of sound. It sounds really phasey. Yeah, but with vertical constant, you don't have to worry about that sort of problem at all.
Right. To rephrase the question, does it mean that also in mixing, if I have some phase issues on my RTW or whatever I'm using, DK audio, if I see some correlation issues between the main layer and the height layer, Do I have to bother this, or are our ears not able to recognize this?
Of course, objectively, when we measure this, the coloration, the conflicting might look horrible, but it's another thing whether we actually hate this kind of coloration or not. When you actually have a slight coloration with some musical sources, it may not be much of a problem in my experience. For like string quartet on orchestra, because it's such a broad band and the music notes always change over time. So this kind of coloration is not so problematic, but with static noise and especially crowd noise and applause sound, I found this coloration is very much of a problem sometimes. Yeah, so it depends on the source type, I think.
Awesome. Let me just see questions. Somebody's writing a novel here in the questions.
I would have a second question, Roger.
Yeah, go ahead, Felix. Sorry.
Okay.
We'll
as a tone master, I try to achieve, if I'm doing recordings, acoustic recordings, I try to achieve the best frequency response. And we all know the compromise of cardioid microphones or all kind of cardioid microphones. Is this or was this a problem for you in capturing crowd sound or the sound in New York, which you did there?
Another good question. Actually, for this recording, I used Sennheiser 8040s and 8050 capsules. For cardioids, they have impressively large low end, the extended low end. They have very impressive low end. So I had to apply high pass filter.
High pass filter, yeah.
Yeah, I had to. But if we use normal cardioids, I mean, I also like Schoep's, CCM 4 and CCM, 4 ones for this type of arrays. And yeah, they have very naturally controlled low end cardioids. I think in general for this kind of ambience noise, I'd rather use cardioid rather than omnis, because omni captures such rumble noise, especially also in concert hall as well. If you're capturing like big pipe organ or big orchestra, of course you need the low ends, but for small ensembles you don't need that much low end, and you can always use the German traditional what's it called, Strauss packet technique.
Strauss packet, yeah, wide card.
Yeah. So you can always extend the low end using some additional omnis, but yeah, for normal uses I don't need much omni.
Yeah, but then I have to change my angle to get the 10 dB.
Yeah. I mean, if you use omni bass, of course you can use omni main layer, but then you only need about 20 to 30 centimeter spacing between the height and main layer. That's because vertically the decorrelation only matters above 1 kilohertz. You don't need a low frequency decorrelation at all. So just about this much spacing is enough.
Is there
It's just a theoretical question, because we anyway do a high pass filter at 100 hertz and higher for sports crowd sound.
Yeah.
Can you cheat the decorrelation with baffles, or are there?
Yeah, actually, that's a good point. Some people actually put like a thick towel in front of omnis, like capturing ambience for the real channels. Yeah, Lasse Nipkow from Switzerland, actually he uses thick towel in front of omnis to suppress the direct sound. And also for 12 cube, Morten Lindberg also uses the ball, the pressure ball, acoustic pressure, the DPA. It basically increases the high frequency directionality, so you can have a more channel separation. And also my unmixing technique called PBA, perceptual band allocation, based on the pitch height effect. I tend to split the frequency band to several bands and then allocate them to either the main speaker or high speaker. So a very simple case would be 2 channel separation. So high frequency goes to the high speaker and low frequency goes to the lower speakers. Then you can have quite effective sort of spread and separation between the 2 layers.
Well, that's great. Well, I think we're going a few minutes over, but thank you so much. That was, fascinating. And I think we're going to see more of these kind of techniques for capturing live events. It's going to be really important as we do more and more. And events and Atmos, live sport events and entertainment events, and having sort of deployable array microphones that are quick to set up and give us these wonderful spatial effects.
Yeah,
It's going to be
definitely.
useful.
Yeah.
I think we're going to jump to Ben, I believe. I've got my schedule right. Ben, I'll give you your glorious introduction. Ben is the director and co-founder of Salsa Sound Ltd. He's also a senior lecturer at the University of Salford's Acoustic Research Center. Salsa Sound started from extensive research at the University of Salford and provides audio solutions for live sports broadcasts. This includes AI-driven automated audio mixing and also the vCrowd app that provides virtual crowd for lockdown games across multiple sports. Today, Ben, I think you're going to talk a little bit about AI and how we're leveraging AI notably for Kick and for other applications. And this is something which we're just sort of starting to understand, but it's a very exciting field. And I think, as we're able to manipulate audio more with AI, we will see this to sort of extend the creative reach of mixers. So, Ben, if you want to kick it off, we'll turn it over to you.
Sure, will do. So thanks very much for the nice introduction, Roger. As Roger says, I'm Ben Shirley. I'm director and co-founder of Salsa Sound, and today talking about shaping sound, or specifically shaping audio objects with AI. So some of the work we've been doing at Salsa over a period of time. So just to go to where we came from, if I can move this on, excellent. It may all work, who knows. So initially, the initial tech that Salsa Sound was founded on came from a development in a large-scale European research project. I was based at University of Salford, and we worked on this stuff. And it all had to be object-based audio because it had to support free navigation of a live event. So the viewer could take their camera wherever they wanted in the stadium. This is at Stamford Bridge where we did our first test shoot back in 2010. So back in 2010, we had to essentially define everything in the scene as an audio object because everything had to be manipulated based on your viewpoint of the stadium, which provided a few challenges, you could say. And that was so that we could present it effectively, whatever the viewpoint, and over any device, mobile devices, TV, cinema, VR, AR, 360 video, and also for personalization. So we carried on working on this after the project finished in 2013 and formed Salsa Sound in 2017. And essentially we were looking at applying some of the techniques that we built up in this 3.5-year research project to existing broadcast systems, and how could this work, how could this help the sound supervisors, how could this help the broadcasters, and more importantly, how could it get a better sound to people viewing live sports. So we looked a lot, and the more we worked with sound supervisors and the more we worked with broadcasters and outside broadcast companies, we learned more and more of the challenges of live sports mixing. And it's a hugely complex task. It's a really skilled role. There are a limited number of people who have the skill set to provide the incredible mixes that we've come to expect from World Cups, FA Cups, Premier League and so on. It's very, very difficult, and there's an awful lot of simultaneous tasks that have to be done. So a number of games that we've been at where we've been capturing sound as part of the development process and so on. The sound supervisor's mixing the game, he's chasing the ball with the faders on the mixing console, and the comms goes down somewhere in the production team, and that's his responsibility as well. So he has to forget about chasing the ball for a bit and deal with the comms issue because that's more important. And obviously the mix suffers for that, and we get some compromises. So we were looking at creating tools that could take some of the pain out of this work, if you like. One other thing is that the kind of fluctuations that you get in the ball group, while they don't matter too much in stereo and less immersive formats, these kind of constant changes that go on when you're raising and lowering faders around the pitch, they really matter when you start looking at immersive formats. And some of the mixes that we looked at with some of these fluctuating ball groups, as soon as you start playing them out of a Dolby Atmos system or something like this, they're no longer masked by the crowd sound so effectively. So they become really obvious. So we started looking at some of those issues, and we developed a kind of artificial intelligence driven automated mixing for those on-pitch sounds. And essentially we've got this neural network we developed, which is trained on many hours of match content. It's fed acoustic features of lots and lots of real games with the knowledge of where all the ball kicks are, where all the referee whistle blows are, where all the salient events that we want to capture are. And then that trained algorithm is used in real-time operation. So it works in real time. It creates an automated mix of those on-pitch sounds in real time, and it works in parallel with the signal path. So it receives a parallel copy of all the microphones around the place, and in one use case of it, it can provide a pitch effects mix for the sound supervisor, so he doesn't have to worry about it, and he can concentrate on making the rest of this immersive content sound incredible and not have to worry so much about chasing the ball. In other contexts, it has other uses, as we'll see. So we took an audio-only approach. We don't know a whole lot about video and tracking, or we didn't know a whole lot about it on this project, so we took a completely audio-only approach. So there's no additional cameras and so on needed for tracking here. And we developed what we started talking about as short-term audio objects. So every time something that's important happens on the pitch, we're essentially, you can probably see in this diagram here, we're using kind of time difference of arrival of the sound at the multiple microphones around the pitch to identify what the important objects are, to pull out acoustic features from that, and to identify whereabouts they are on the field of play. So potentially all of these ball kicks could be, and indeed in this initial research project, because we had to be able to experience this in 360 video, all of these initial ball kicks were 40 millisecond long or so audio objects, which had their own associated positional metadata and metadata about the kind of object it was, whereabouts on the field of play it was, and so on. So we can isolate these objects for individual processing, or for shaping of the sound of these individual objects. As I say, these short-term audio objects were extremely useful for kind of 360 video, immersive VR purposes. But we can also think of it in terms of a pitch effects object, which could be manipulated by the sound supervisor and controlled by the sound supervisor. And we're also generating this rich real-time metadata of where the action's happening on the field of play. Every time there's a ball kick or whistle blow, we know where it is, and we're tagging metadata onto that. So it works on arbitrary microphone setup. So one of the things that we decided was that we didn't want to add an additional hardware requirement onto broadcaster and outside broadcasters. So we initially, because we weren't allowed to, because we had what we were given, but we worked within those constraints, and wherever the microphones are, it essentially creates a constant power pitch effects output, which can be sent into the mix. So there's none of that fluctuation in the center channel from the raising and lowering of faders. It's a constant power output because it's a machine doing it. It knows to make it a constant power output. And these the microphones are all fed into this trained neural network, which does the object detection and either creates an automated mix based on those pitch side mics, or it can also enhance those in different ways. So usually a MADI or Dante input, as I say, it's in parallel with the main signal path. It could be an automated or an enhanced mix. So in its simplest form, it's essentially replicating the role of the sound supervisor, but creating no fluctuations in the center channel. So it's a steadier, more predictable ball group, if you like, for immersive audio. But what we can also do is, nobody's going to pick up those ball kicks right in the middle of the park that are nowhere near any of the microphones, but the neural network can detect those, and it can pull lots of acoustic features out of those. You might not be able to hear it on any of the microphones, but we can detect it and we can understand quite a lot of it. So we introduced the idea of having a bank of many ball kicks in samples, and we would pick out the best fit from those and play it out at the appropriate location at the appropriate place. So if you wanted to, you could have those additional kicks that no microphone's going to pick up all right. Again, this becomes much more useful when you start talking in 360 audio and VR enhanced and so on. So you've got this choice of a couple of different mixes or a combination of the two. And the idea is that this could be a multi-format output, so it takes all the microphone feeds in, and it can put out, back out full B format ambisonic mix, it can put out stereo, it can put out binaural. In fact, it can do all those things simultaneously. So we can have multiple automated mixing for different audiences. And I think this is where it, it becomes slightly more interesting, because different people who watch the same game of football, for example, have different requirements from it. And we did quite a lot of work, are still doing quite a lot of work with Manchester City Football Club. And what they were interested in was putting their fans, who may never get to the stadium, this is pre-pandemic, so it may never get to the stadium because they live in China or the US or wherever they may live, but they wanted to put them virtually in the best seat of the house at the Etihad, with the sound of the crowd all around them, and to give them that whole experience. And it's impractical to put an extra OB truck, another sound supervisor, and somebody else creating that mix. So we provided this technology so that we could provide multiple automated mixes, but for the different requirements of different audiences. So to give you an idea of the kind of ball group, hopefully we'll be able to see this, I think. If I just play through the ball group sound, which is taken from one of the games that we worked on, where you can hear those kind of fluctuations. And this is the ball group, which is generally placed center, so it sounds like it's coming from your TV. It's just mono, so don't be alarmed if you're not hearing immersive audio at this point, because it's just a mono feed from the mixing console. So you can hear the fluctuations there, and that's really not a problem when you have a stereo mix, and it's masked completely by the crowd, and you just hear those ball kicks. But we have a automated version of that, which is doing this constant power output, and while not a perfect automated mix, it does make it a very predictable ball group, which you can place in the center. Playing the wrong one there. I'm playing the bad ball group. Let me play the good ball group. So hopefully you can hear that's a kind of constant output going on there. It's predictable. So you put that in the center channel of an immersive audio mix. You know what it's doing. You know that you can mix that, so it's going to mask it okay. So let's just have a look at that in context and think about how we do this automation for multiple different mixes for different audiences. If I can advance the slide without actually playing anything else. Here we go. So this is taking objects beyond just it's the commentator or it's the ball group or whatever, and we're saying that anything on the pitch can be an object, and that might be just in the production domain, where in the production domain they're deciding more of this object, less of this object, and so on. So ball kicks can be, the crowd sound can be. So if I can just play an example here, if I can share an additional screen. And here's an example of it in context, so that you'll hear three different clips. The first one is broadcast output without the commentary, so that you can tell what's going on with the sound a bit better. And then a binaural mix, which is automated by the Salsa tech. And then a third mix, which is the fan experience binaural mix that the box put together for Manchester City. So if I can just play a little bit of that. that forward a touch to the first mix that was coming out of the box. And finally, the fan experience mix, which was the one put together to put people in the heart of the stadium. And again, we had an additional sound field microphone. We were lucky enough to get access to the singing section at the Etihad to put the microphone in, which gave us an extra option in terms of what we could automate. So I'll just run a little bit of that fan experience mix. So you can see there's some quite different mixes there, that we don't need additional outside broadcast trucks, you don't need additional desks, we can just create that automatically. So it's essentially using every item of the mix is potentially an object which could be maybe chosen by the viewer at home, their particular mix, or maybe chosen by the production team. So we've moved on from that now. What we're working at the moment and over the next couple of years is we're working with BT on this DCMS funded project. So this is taking the kind of AI that we're doing into the cloud this time. So we're doing all of this automated mixing in the cloud and creating viewpoint specific audio so that you can manipulate that in a VR, AR, in whatever kind of world you want, with multiple different ways of customizing the audio, enhancing the audio and so on, creating automated mixes for replays so that the viewer can watch what replay they want to watch. And alongside that, there's a bunch of audio analytics that come from the kind of metadata we're generating. Also, because we're presenting all these opportunities for personalization, we're creating opportunities for accessibility and improving the accessibility for people. The fans who we worked with in various focus groups from Manchester City, the top thing in their list was they didn't want a commentator. They didn't want somebody else telling them what they should be thinking about the game, because they knew the game and it was their club and they knew all about it. So that was a priority. If your viewer is visually impaired, for example, they may want extra commentary. If they're hearing impaired, they may want a different mix of the commentary against the rest, and so on. It's all audio. Sorry, yeah.
Go ahead, Ben. Sorry.
And we're looking at multiple devices, so augmented reality, personalising the audio and so on. And that's what's going to be happening over the next few years. And I think that's my time up, possibly slightly over.
Yep, there you go. Ben, that's really fascinating. It's interesting, the idea of just a different fan experience in the stadium as being a personalization. We always think about alternate commentary and things like that, but that's really... And your sort of research says that you've had a positive response to that idea of somebody who wants to just hear a more immersive fan experience. It's interesting too how many people in all kinds of sports would rather watch the thing without commentary, and that's a very sort of disruptive concept to some broadcasters. But
one of the things we learned when we were doing you mentioned about doing the V-Crowd, the virtual crowd stuff since lockdown, which we've been working with a bunch of US clubs and leagues and broadcasters and so on. And it's incredible how different the crowds for different clubs actually sound. And when we've been working on that virtual crowd stuff for during lockdown games, you just can't play the same crowd sound for two different grounds. The fans see it, they get it. And if you do it based on the recordings that are made of them at the ground, they feel at home. They know it's there. There was one guy from one guy from the focus group when we did that fan experience mix knew exactly where the microphone was, because that's where he sat in the stadium and he recognised what it sounded like.
Oh, that's interesting. What are the real-time considerations of the AI, and is there a delay advantage to delaying the audio, or where do where's the sweet spot there?
So initially when we did this, we thought, what we need is a time machine, because we need to be able to do all this processing and build all this mix and so on in real time to go out live. It's never going to work. What we're going to do, and then we found our time machine, and that's the video processing delay, which takes a couple of frames, and we do all of our processing in about 80 milliseconds. The trained network does everything in about 80 milliseconds. That's including playing out all of the stuff. So essentially what we do is say, don't delay the audio, just stick us in there instead.
Yeah, well, the rest of the audio, the whole audio would have to be delayed.
Yeah,
the whole audio a couple of frames.
We did a integration piece with one of the larger outside broadcasters, and essentially the way they found that was the best way of doing it with the sound supervisor in there, so using it as a tool to enhance the mix rather than as a purely automated mix for a different audience, which is another way of looking at it. And the way that they found was essentially using 2 layers on the desk, and the sound supervisor was mixing the undelayed audio and there was another layer which was the delayed audio, and that worked really well, and it was relatively easy to set up. The challenges that we're looking at with this project with BT are looking at kind of edge computing and cloud computing, and essentially bringing the neural network and the training closer to the ground, so it can do more than just, essentially at the moment we're training the network and then letting it loose into the wild to do its job. Whereas we think that by moving the training closer to the actual event, potentially into the stadium with edge computing, we can actually move some of that training into the game itself and learn during the thing. So then that sets different latencycy on challenges.
Well, how processing intensive is this? Is this something that can this go on a standalone?
Yes.
So
the
or does this lend itself more to being in the cloud or in
the training itself takes time. It takes quite a lot of time and quite a lot of content. Once the network's trained, it runs on a fairly standard machine. So we run it on a MacBook when we're developing.
Wow.
Without any issues. We've done installs on some of Dolby's units. We've done installs on some fairly standard Dell servers and things, which we've just added some nice MADI or Dante sound cards to in order to get the audio in there. But it's not a big processing footprint once it's trained.
There you go. Well, this is fascinating, and I think this is an opportunity to give an enhanced experience, to add more, and I hope that we can sort of embrace how technology can help us create better experiences. But really fascinating. Well, I think we're running a little behind. Well, I think we'll keep going. If Felix, if you're feeling ready,
yes, I am.
We'll jump onto your thing here. Since 2018. Felix has been the professor for broadcast production and system design at the media campus of the University of Applied Sciences, Darmstadt-Dieburg, and takes care of upcoming generation of TV sound engineers and supervisors. Felix has been in the broadcast industry for the last 20 years after graduating the renowned University of Music at Detmold as a Tonmeister. Working with Lavo for 15 years in product development and business development, he's gained experience in modern broadcast workflows. One of the major topics in Lavo was the development of the M² series from 2004 to 2013, and the development of IP-based systems such as Lavo Commentary Unit and the video line. Felix still regularly mixes for the last 15 years surround and Atmos sports productions such as Bundesliga EuroLiga, Championship League, and World and Euro Cups. At university, he conducted several tests and research involving improving immersive and object-based sound creation. How's that, Felix?
That sounds really cool. Thank you very much for this nice introduction, Roger.
So nice to see you.
Yeah, very nice to see you across the sea. First of all, I share my screen before I forget this, because you start talking and you forget you have to do another thing. That's different in digital presentations. Yes. Now we will talk a little bit about the challenges for the audio mixer to manipulate the objects. And I'm not just talking about the objects in terms of NGA objects. I'm also talking about the objects in general, which we all put together in a mix. And let's perhaps first try to figure out, why do we have now a problem? I mean, we are mixing sports sound for many, many years, for many decades. And we have done a good job in stereo. We have done a good job in 5.1. We have also done a good job already in mono. But suddenly now this beautiful new technology comes up with Dolby Atmos and immersive sound. And we have new problems which we thought they are already behind us. Just think about what we do, what we put together. And I'm just using 3 objects here, which is the main objects typically for any sport sound, which is the crowd to put you into the arena, which is, I should have written here, field of play, but we all know football is dominating sports, at least in Europe. It's the close ball sound, and it's the commentary. And in stereo, they are all in one layer, they're in one line in front of you. And we also know, different to cinema sound, we don't have clean sound coming out from the commentary microphone as well as from the closed-ball sound. Apart from right now in pandemic, we have very nice closed-ball sounds, but there usually is crowd in the stadium, and it gives us this spill here. So there's also a lot of crowd in the closed-ball sound, and you could see this in Ben's nice example. I'm always telling the closed-ball microphones, more or less all microphones for field of play, have 90% or even more sound from the crowd. And the same applies for commentary. Also, commentary has a lot of spilled sound from the crowd. In stereo, we can see this. It's really nicely masked by each other. You can't really differentiate. Apart from you are very experienced, like the sound engineers, but a normal consumer at home, they can't figure out whether the crowd sound in the center is from the real crowd microphones or whether this is from the closed-ball microphones, whether the commentary crowd sound is coming from the crowd microphones or the commentary microphone. So everything is more or less masked by each other, and any problems which we have in a non-constant output of the closed-ball group is masked by sometimes even the commentary signal, as well as, of course, the crowd microphones. And of course we put little correction for you, Ben. We put the crowd, of course, in the center, but we put it always in the phantom center. In stereo anyway, it's in the phantom center, which means for us, for the speakers left and right, the crowd sound of the closed-ball microphones are coming out from the same speakers. This applies also to 5.1, where we have the microphone, the closed ball, in the phantom center. So it's typically put into the phantom center and not in the real center. Why? We will see quite soon. The commentary, which is more or less an international agreement, I wouldn't say it's a law, it's an agreement that we put the commentary in the real center. And now the following happens. If we have still that much spill, or if we don't have a proper mix with this power matched output coming out of a system like Ben's system, we figure out, due to the cocktail party effect, much easier in surround, because the crowd might come more from the real left side or from the rears. And in 9.1, 5.1 plus 4, it's coming from the hide signals. And the difference in sound shaping, because this sounds completely different, I wouldn't say perhaps not completely different, but it has, in my case, quite often I'm using the Schoeps microphone, the OITF 3D or the 2D. It has a much nicer sound than the closed-bore microphones themselves. And of course, we have to treat the closed-bore microphones in terms of EQing and compression, and nowadays more and more also a couple of special effects like plugins, which also applies to the spill we have left and right in this closed-bore group. So the difference of crowd sound from the closed-bore group and the crowd sound from the real crowd group is revealed a lot more in 5.1, and of course this even takes place worse if we go to 9.1. And quite common, we have dedicated crowd microphones left and right, which gives us much better localization. As a tone master, I would say it's the spot microphone in front of the instrument, which gives me this very nice and clear localization from the left-hand side, which would be in Germany, the Dortmund huge arena, 20,000 people sitting there. And on the right-hand side, I think we have this on Saturday, it's Bayern Munich on the right-hand side. So a really big game, and we want to localize this back home, that two stands are on the left-hand side and the right-hand side. Again, if you're focusing more on left and right, it reveals your spill of your closed-bore group as well as of the commentary group. So this is one of the main problems we have when we go higher, let's say higher order immersive sound. Stereo is also immersive, but if you go to 5.1, 9.1, and like in Japan to 22.2, the individual objects are revealing their problems a lot more than we ever had this in stereo. Yeah? If we are rude, we could say in stereo, you can do whatever you want to with your crowd group. It's masked by the closed-bore group and vice versa. And this is, of course, then unmasked by 5.1. The second problem is, which is also a beauty, it's the beauty of presentations. We have now these new tools, and we can offer different mixes. Same like we saw with Ben's tools, and we have this in Dolby Atmos. We can create multiple presentations. For example, a very dedicated presentation with just closed-bore, and this even with more level in terms of the amount of the level into our main mix, into our new presentation mix. And just a little bit of crowd left and right. And why would we do this? It's an idea which came up 2 years ago with the guys from Dolby and the guys from HBS during the World Cup in Moscow in Russia, that we create a special presentation for the pub. And if you think about the experience you have in a pub, if you have ever been in a pub for a big football match, then there is already crowd in this pub. People are cheering, people are clapping, people are applauding for their team, and usually this is very, very loud. There is a high noise level in crowd level in a pub, which means we don't have to add another crowd. They don't bother so much about a nice glued together surrounding immersive crowd sound. They want to hear what the referee perhaps is talking to a player. They want to hear the ball kicks. They want to hear, and don't get this wrong, they want to hear the bones which are broken whenever there is a rude attack. Yeah, and of course we can add some dedicated crowd, like the crowd which you heard before, very, very close and in the crowd, and we did more or less the same. And with this drawing, you see even more. There's complete separation, and we could say in our sound presentation, in our special pub presentation, we have this separation. Means we have to make sure that closed-bore is sound quite well, that is sounding very well, that commentary is shaped properly, as well as the crowd sound for left and right. Which means for us, we have to handcraft the objects, the groups, the microphones, everything which is put together to get these presentations, to get this immersive sound much more than we had to do this before, because it's revealed to even the end consumer. It's not just figured out by a professor or whoever is sitting behind you. It's revealed to everybody who is back home on headphones, on iPads, on speakers, etc. Which means, first of all, I can recommend to choose the right microphone and the right microphone setup. And we heard already today from Hyunkook how we can achieve a proper and good sounding crowd sound with the tools he had and with the findings he has. Secondly, like a little bit like a tone meister, when you do a music recording, you really go to the instrument and you find the right spot for the microphone. We have to do the same for our pitch microphones. Yeah, I quite often see, and this is just an example how you could do the microphone setup for a soccer match, for a football match. Quite often I see that this would be actually the ideal position for a shotgun microphone, and we know that the frequency response off axis, so off axis of 0 degree, is getting worse and worse, and perhaps you can say that's plus minus 30 degrees that there is a good frequency response to capture the ball kick. I always say a ball kick is a little bit similar to a bass drum, a kick drum, just the main frequency, the Grundton in German, to be honest I don't know what this is in English, is slightly higher compared to typical kick drums, but we boost a little bit the low frequencies, 120 hertz, and we boost, of course, the kick, which is at more or less 3.8K, 4K. The microphone is losing, especially the high frequencies, the more you go to the right. Quite often I see this one here, which means more or less the good area of this microphone we lose completely. We are not using the possibility of this microphone capturing good field of play sound, because it's pointing, this angle here is pointing to somewhere, to the referee, perhaps to the sideline referee and to some crowd, but it's not pointing to any close ball. At the same time, our good line here stops much earlier compared to where we had this before, which was here. So whatever happens here is not anymore captured with good frequency response from this microphone. So think about the way how you position your microphone on. Frankly speaking, I'm double checking, same like I would do a symphony orchestra or a string quartet. I'm verifying every time the right angle, the right height. Sometimes I see microphones pointing to the sky. There's nothing in the sky. The football player hits the ball quite close to the ground, apart from a Kopfball, apart from a head kick, you probably would say. So this is the first thing which has to be chosen, as well as, and this is handcrafting again, get these microphones all in with the same gain or a similar gain into your mixing console with very little EQing on an individual microphone. You heard this example before from Ben. Whenever there is a microphone which is faded up, which sounds different to another microphone, let's say 10 sounds completely different to the microphone 9, this is revealed by our presentation. This is revealed quite easily by our new immersive sounds. Then secondly, our conclusion way too early. Secondly, make sure that in your mix, and you should be able now to see my screen, make sure that all the parameters, and I just pick out a few, are set properly. You saw before, I quite like to have a main microphone for the crowd plus a spot microphone. And this is quite complex setup, which I set up 1.5 years ago when I did this research with new spot microphones for 3D mixing. This is a microphone which also has the height information. It's more or less the left half and the right half of an ORTF 3D. Now I will play this content, and first of all, it's delayed properly, which means we have a delay implied in our ORTF spot microphone, which applies quite accurate to the main microphone. And on purpose, you don't hear any close ball, no commentary. Okay, we can stop here. Twice the hoo-wah. Now I switch off the delay and let's start again. Just the main microphone and the spot microphone. you see, or you better hear, there's even an echo because I have to apply a lot of delay. The microphone was something like 85 meters away from the main microphone, so I applied almost 300 milliseconds of delay into this crowd spot left microphone. If it's not applied, we have more or less a mess of everything everywhere. Second example now would be our famous pub presentation. For this, we switch on commentary, we switch on a little bit of dialogue, and we bring down the main bed, and let's listen to this one here. Bring up close ball a little bit more.
So, die Davi, 3 Mann im Elfmeterpunkt, 2 vorne dran. Hoppala. Die Davi, Sommer auf dem Weg, Sommer auf dem Weg. Resolut, ein Stuttgarter liegt da noch, da ist Hazard, hier drüben ist Hofmann. Zieler da, Hofmann, klasse Trick, Tor ist leer, bringt er in die Ecke, nein. In der Mitte wartet Player, drüben Hazard. Stuttgart schmeißt sich rein und noch ist nicht vorbei, Kramer. Neuhaus hinten Hofmann.
Switch this off here.
So, die Davi, 3 Mann im Elfmeterpunkt, 2 vorne dran. Hoppala.
Commentary was amazed by the close ball sound.
Die Davi, Sommer auf dem Weg.
So the live mix was more or less the same. And you figure out already, there's a lot of crowd in the close ball sound, and we heard already something like 5, 6, 7, 10 different microphones. All faded out automatically by another software, the software which is developed by Lavo, which is the Kick software, but it gives us the same result, that we have a power matched output, especially for the spill, especially for the crowd sound, which is coming through the close ball microphones. So the second example of how important handcrafting is, it's the software, new software which we have available nowadays, but also the right microphone selection and proper EQing and gain settings in the complete signal chain. And then, same example, let's go into this example again. I present you what I quite often observe, what I quite often see is how commentary is treated.
Nein, das für mich kein Foul. Körpereinsatz. Und dann ist es Sosa, der den Ball da vorlegt. Jetzt habe ich gedacht, Hofmann bringt ihn noch um die Ecke, tut er nicht. Und dann zu viel Stuttgart und zu wenig Chance. Jetzt Jetzt sind noch die Stuttgarter Ergänzungsspieler auf dem Weg zum Warmmachen. Castro, diesmal bleibt Sommer im Tor. Ui, sehr eigenwillig. Foul Hermann.
Like this it can be, and it's on purpose that I'm showing the RTW, because there's just commentary in the center in my mix. And crowd sound coming from the crowd microphones is left and right. Quite often I see this one here. That, let's accelerate this a little bit. Don't care about the true peak, there's no limiter implied in my TW. Quite often I see that this level is more or less the same, or even with the beautiful plugins which we have, another compression in the signal chain, and right away you hear the spill sound of the commentary coming from the center. In terms of loudness, it's more or less the same. I have the same balance of crowd sound and commentary sound, but I have crowd more or less only coming from the center channel, which is revealed a lot more by 5.1 and 9.1. Let's switch off again the way too many compressions and go back to a setting which also gives us the same dialogue intelligibility. And you see, the crowd immediately is going down. Yeah. So you can use the tools you have today already. We don't need any new tools to handcraft your sound in a better way. What does it mean for us as a conclusion? Technology drives creativity. I mean, you see there's coming up a lot more presentations, a lot more mixes, a lot more offerings for, in the end, our end customers, which is not the production team, which is the home viewers at home. We can offer them more content to see a match. But even more interesting for us is technology is forcing us to improve our skills, to improve our handcrafting ability to provide them the right sound for these new experiences. And that's it from my side, Roger.
Oh, that's great. That's fantastic. Really interesting. I guess, you know, one of the things, and this is a question, Felix, for you and for the whole group, but it really, this underlines how important it is to manage delays, and that becomes, you know, very critical. And I guess, can we start to develop, sort of codify the rules of managing those delays? And in Bundesliga, you have a sort of a standard microphone setup. It's very repeatable. Are you able to sort of template that delay strategy?
Not really. Yeah, I forgot to explain how I do this. I mean, you could go to each stadium and measure the stadium with whatever, a laser which is able to measure the distance of the microphone. I would say for a real important match, the cup final, for example, 1 year ago, I put a A2 out to the stand left, and you had a plastic bottle and something metal, and you had to clap all the time to figure out delay. But you can make your life much easier. Train this a little bit. You can hear the delay of the stand left and right quite easily when the players are announced by the stadium announcer, which is usually way before the commentary starts. It's something like half an hour before they kick off. Whenever they say, for example, in Bayern Munich, and the striker is Robert, and everybody is saying Lewandowski from the Bayern Munich side. And the same applies for Dortmund. And the defender is Mats Hummels. And this Hummels has to be delayed properly, that you hear it just once and not twice. So you have 11 times the chance to get your delay right.
Well, I mean, I guess this is just, shoot the same question over to Hyunkook, is this something that as we do this more, we really have to start developing some rules about, as we're putting up, particularly as we're putting up these arrays, that are then mixing with other effect microphones. We just can't do it willy-nilly. Hyunkook? Are you muted? You're there.
Yeah, regarding the delay match.
Yeah.
Yeah, I think that's a really important aspect. Actually, I could clearly hear this echo effect when Felix played the demo. But I guess maybe there is. Yeah, if we use this kind of like ambience array, especially like a highly directional microphone arrays, if we used, for example, high-order ambisonics and things like that, the localization will become more precise, with the ambience array, so we can actually locate where the, each part of the crowd is and all that. In that case, yeah, definitely delay match will be very necessary. If we just use the ambience just to fill the gap, like filling the space in general, then maybe it may not be so important. But I think it's also the balance between the spot microphone and the main microphone, and depending on how much of each you use in the mix. Yeah, but I agree that we need to have some sort of, maybe it would be convenient to have a standardized way of matching the delays and automatic calculation of it and all that.
That would be very helpful.
Well, Felix, you talk a lot about art, but some of this is sort of like these principles that are emerging principles, which we need to articulate in such a way that says, worry about this, not just relying on, the mixer figures it out and he or she knows to do the right thing. It's just like, okay. And the commentary microphones, of course, in England, they use the Coles microphone, so you don't have the
very close.
You don't have quite the problem.
It's still quite bad in a lot of stuff because there's still quite a lot of crowd on that microphone because it's quite loud where they are. Yeah. And we noticed we did a bunch when we were putting some of the mixes together for Salsa very early on in a Dolby Atmos room in a dubbing theatre, and as soon as we added the commentary in, it collapsed the crowd towards the centre, and you had to mix with the commentary there in order to get it right because there was still a substantial amount there.
Well, but I can tell you that even in the most noisy stadium in Germany, we have Gelsenkirchen, something like 110 dB A and more. I promise you, with the right gain settings, you can get along with it. It's of course, we have a lot of trouble in the audio control room, and there's a lot of stuff going on. But if we start already compression, or the commentary hitting the compression when he is talking quite silent, like I'm doing this right now, then of course, if the crowd goes a little bit crazy, the crowd comes up to a level where we can recognize it quite easily. A sound which is that low, there is no compression necessary. It shouldn't be already compressed when the level is quite low. And this is the handcrafting skill set and tools I think we have to rethink about. We were used to, we have to compress because we are in TV and there's not a lot of a huge loudness range which we are allowed to use. It's completely different to a classical concert. Everybody knows this. It's quite easy to understand, but we shouldn't misuse all the new tools which we have, like plugins and compression and too much compression, etc., etc.
Well, that's a sort of automatic thing too. The mixer is so concerned about catching the commentary that there's an automatic knee-jerk reaction to over-compress, which doesn't necessarily, further that much, but then it does mean that you're getting this pulled up noise floor, which is making things, making things worse. Yeah. You mentioned phantom mixing, and Ben, you had a great example of the fan experience where you're not putting commentary in and then you're letting the fan experience fill in the center channel, which was very compelling. But we tend to do this 4-channel effects mix with nothing in the center, and do we need to evolve that to have more covering ambience in the center? What is that sort of part of the problem, or we're relying on the commentator to always have the covering ambience? What's the You know, what's
I think it depends so much on what you're listening on and what your requirements are, on what you want to hear. I mean, Felix's pub mix is a really nice example of that. So it's a mix that's crafted for a specific situation, and the mix was put together with that situation, and it works for that situation. And if you're watching it in a quiet living room, it wouldn't work so well. So I think there's a really kind of compelling case here, rather than saying, you know, should there be more of this in the centre or more of this and that, of saying it's about, you know, it's what objects make possible, isn't it? It's about personalising it for the reproduction device and the audience.
Well, Ben, are we kind of like, we have this sort of really simplistic idea of personalization, and are you suggesting that we sort of need to evolve to think about personalization, maybe kind of a completely different mix, but that has a sort of a different center of gravity, I guess I would say, and is the pub mix is an example of that?
I think it's just a matter of time, but I mean, obviously it's early days of personalising with objects, so we start small. But I think there's certainly the pub mix is a great example. The fan experience mix is another great example. Both of which, I presume the pub mix has gone down extremely well. Certainly the fan experience mix, the fans loved it, and they were, you know, there was some research commissioned by the club, and people were saying they would renew their subscription if it sounded like this kind of thing. You know, there's money in making a personalised mix. It's not just a purely aesthetic thing.
No, it's money.
Yeah. So I think there's really strong argument for taking personalisation beyond just having a different commentator, because a football fan or an American football fan or a basketball fan, they want to be in amongst their people watching the game. They want their fans around them, that particular experience.
Yeah. Well, you know, it's interesting. We've all sort of got immersive under our belt, I would say. It may not seem that way, but we're kind of, it's becoming the standard on premium live sports or entertainment. But I think that sort of personalization is where we really need to, where the next challenges are. And there's a lot of runway there, and there's a lot of interesting stuff we can do. And obviously accessibility is really important, and particularly, you know, for people who may have hearing challenges or things like that, who need better dialogue intelligibility and whatnot, but also just for completely different fan experiences. And it's not just, and as we move these sort of, we think about production more in terms of stems or objects that are then can be manipulated in sort of different ways in the cloud or however they're delivered, that and we can get some confidence in that. There really could be radically different presentations for different markets or for different users, and we've probably got years of sort of thinking about that and experimenting with that, I think. So I'm looking at the questions. You know, there's sort of a couple of questions here, and I'll pick on one of them was, you know, do we see AI as what's the end game for AI? And, you know, Felix, you talk about training next generation of engineers, but is AI gonna play a larger and larger role in this? And how much, and this is a good question for you, Ben, too, is can AI play a larger and larger role in this? And where's the end game? Or will we see certain sports that are not on the level of league football being done with AI because of economics?
Probably both. I suspect the handcrafting that Felix has described so well is, you know, that creates an incredible mix. That creates a really, really compelling mix. It's very hard to do, and not many people can make as good a mix as that. And things go wrong because their attention's diverted elsewhere, and they have an awful lot of stuff to do at the same time. So I think AI could provide a useful set of tools that can allow sound supervisors to create awesome mixes. But certainly it has uses in terms of being able to afford to broadcast events that you might not be able to send a crew of 40 to cover. Sorry, Felix, over to you.
I totally agree. I think AI, or let's say for me, I actually don't care whether this is AI or whether this is just clever algorithms which know every situation. It's about automated processes. Just think about the different presentations, and I'm just talking about, let's say, 3 or 4 presentations. And we, as a sound supervisor, doing a live match, we are not offline somewhere and guarantee that all these mixes work well. We are in a live situation. I have to measure and I have to listen to all the 3 and 4 presentations, which wouldn't be a big deal. But I have to measure all these different presentations in 9.1, in 5.1, in stereo, in binaural, etc., which means I have to pick the most important listening scenarios, because this object-based mixing offers the end consumer to play it out on a 3.1 speaker set or whatever he likes to. So because we have to flip through all these different scenarios, we can't anymore make sure that the mix of the closed-bore microphones, as an example, is done properly. I have to pay the attention to something else, and this, I'm pretty sure, will be more and more the case in the future. And I think, Ben, this mix everybody can actually achieve, and especially your tool helps them, because this power matched output is now there. Only a few people, and I never, to be honest, I never heard a field of play mix that accurate like the one you just played, or the one which is coming out of Kick. So the most talented sound supervisors, they can provide this mix, which means we need AI. And once we have AI or clever software, which is providing this perfect power matched output, everybody can provide this output. They just have to choose, again, the right microphone, the right gain settings, which is still a job to do.
Well, it's interesting. I'd like to think that technology is going to help us do better and better sounding mixes. Well, listen, this has been fascinating. I know we've gone a few minutes over. I notice everyone sort of stayed with us. I appreciate your staying. This has been a great opportunity. It's so nice to talk to the 3 of you guys. Want to thank SVG Europe and their event partner, Dolby Laboratories, for putting this together, and thank Andreas for his presentation earlier, and obviously thank Hyunkook and Ben and Felix, and Will Strauss and Veronica Newsom at SVG Europe, who organized all this and held our hands through this whole thing. I want to invite everybody who's on to our next session tomorrow, again at 4 p.m. GMT. We'll talk about augmented stadium sound for Bundesliga and Premier League, and with some of the guys from Sky in the UK and in Germany, from Kevin McHugh and Alessandro Rotano, and everybody. It should be really should be an interesting session. But this has been great. It's been really nice to join you all, and great to see you. And thanks very much.
Thank you.
Thanks very much.
Yeah.
Bye.